In section 3.6, derivatives of logarithmic functions, we left off here and we want to find the following derivatives. So if I do f prime of x, so the first one, that derivative would be 5x to the fourth, and then plus, the next one would be 5 to the x times the ln of 5. The next term, 5 to the 5, that's a constant, so the derivative of 5 to the 5 would be 0. And then plus the last term is x to the 5x. So we have a variable to a variable power, and we don't know this one. So that's what we're going to be learning how to do next. So we know how to differentiate a variable to a constant power, a constant to a variable power, a constant to a constant power, but we don't know how to differentiate a variable to a variable power. So to differentiate a variable to a variable power, you have to use logarithmic differentiation. So this is the differentiation of the four cases for exponents and bases. So in general, there are four cases for exponents and bases. Number one, the derivative with respect to x of b to the x, where b is a constant, and n is also a constant, b to the n. That derivative is 0. And then number two, the derivative with respect to x of f of x to the n power is going to be n times f of x to the n minus 1 power times f prime of x. So we know that one, that's a chain rule. And then number three, the derivative with respect to x of b to the g of x power. So you have a constant base raised to a variable power. So it's going to be b to the g of x power times the ln of b times g prime. And now the fourth case is to find the derivative with respect to x of f of x to the g of x power. We have to use logarithmic differentiation. So number 4 is the one we're going to be using right now. So they want us to use logarithmic differentiation to find the derivative of the function. So first thing you want to do is you want to ln both sides. So then you're going to have ln of y equals, now we can use the log property to bring this ln of x out in front. So we'll have ln of x times the ln of sine of x. I'll just put those things in parentheses. And now we use, now we're going to differentiate both sides with respect to x. d dx and d dx. So this would be 1 over y, and then dy dx, using the chain rule, equals, now ln of x times ln of sine of x, that's a product, so we have to use the product rule. So it's the first function, it's the first function, ln of x, times the derivative of the second, which would be 1 over sine of x, and then times the derivative of the inside function, which is cosine of x. Now I'll just call that over 1. And then plus the second ln of sine of x times the derivative of the first, which is 1 over x. And next thing I'm going to do is I'm going to multiply both sides by y. So we get dy dx equals y times, and I'm going to simplify what's in here, so I'm going to have ln of x, and then cosine of x divided by sine of x is cotangent of x. And then plus ln of sine of x, and that's all divided by x. And now you have to remember what y is. Y is this quantity here. So I'm going to replace y with that. So dy dx would be sine of x to the ln of x times ln of x times cosine of x, or cotangent of x, and then plus ln of sine of x divided by x. So that would be a swell answer, or if you wanted to get a common denominator, multiply top and bottom of this by x, we could have dy dx equals sine of x raised to the ln of x times x ln x cotangent of x plus ln sine of x, and all of this divided by x. So that would be a swell answer. Excuse me. Okay, in number 11, we're going to ln both sides. So we end up with ln of y equals, bring the cosine of x in front, so cosine of x times the ln of ln of x, and now we'll take the derivative with respect to x, both sides, d dx d dx. So the left side is going to be 1 over y dy dx. And the right side is a product, so again we have to use the product rule. So it's the first function, cosine of x, times the derivative of the first, which would be 1 over ln x, and then times the derivative of the inside function, 1 over x, and then plus the second function, ln of x, times the derivative of the first, which will be negative sine of x. And just like we did in the previous problem, we'll multiply both sides by y, so dy dx equals y times this quantity. I'm going to write cosine of x divided by x ln x, and then minus ln of x times sine of x. I don't really think it would be beneficial for us to get a common denominator in this case. So the last thing I'm going to do is, instead of this y here, I'm going to write that. So then dy dx is going to equal ln of x to the cosine of x, and then times this quantity, cosine of x over x ln x, minus ln of x sine of x. And I believe that is the end of 3.6.